As always, if the video is going too fast, pause it or rewind it. And make sure to write the questions on the left-hand side. I will do number 1 again for you. And make sure you do number 2 and number 3. The first idea is buoyant force. Buoyant force is an upward force that keeps an object floating or immersed, which means covered in the fluid. So in these two pictures, they're both experiencing a buoyant force. The buoyant force is a force that the water causes that pushes the objects in all directions. Now, you're like, well, why is this second object here, the oak, why is that one deeper in the water? Now that has to do with the idea we learned the last time about density. The denser it is, the denser the object is, the more force it has pushing down towards the water. So the force overcomes more of the buoyant force. So the density of an object has a relationship to the buoyant force. Whenever you have a container, or you have, even if you're talking about the ocean, the pressure is always going to be greatest at the bottom. You know that because since water has weight, there's atoms everywhere, these like H2O atoms. Then there's the weight of them all. This is where the pressure is going to be the highest because there's a lot of atoms squishing down on it. You feel that when you're like at the pool. When you're in the pool and you're diving down into the bottom of the pool is where you feel the greatest pressure. Now, since the bottom of the pool is where you have the greatest pressure, the greatest buoyant force comes from the bottom. As you go up here, the buoyant force is weaker. So buoyant force is a force that pushes an object that is in a fluid. Number 2. Archimedes. This is the person I told you that he put a crown in water, a crown of gold, because he wanted to find the density, he wanted to find the volume too. He created this principle that states the buoyant force in an object is equal to the weight of the volume that the object displaces. This picture should help out. So let's say you put an object like that one in that picture. Now the object, let's say this was in a container. And when you put the object, some water can come out, depending on how much, of course, the object is dipped into the water. The water that would come out, so the water that is displaced, which is this little container, if you're able to catch the water, this water here is equal to the volume of the water that was displaced. So if the object was like 5 centimeters cubed, then the water that's displaced is also going to have a volume of 5 centimeters cubed. And another thing that Archimedes' principle says, that whatever the weight of that water is, let's say the weight of that water is 2 pounds. If the weight of the water is 2 pounds, then also the weight of the object, the weight of the buoyant force will also be 2 pounds, 2 lbs. Go ahead and finish writing that up, and then write a question for number 2. Make up your own question for number 2. Number 3 says, changing the volume or the mass of an object affects the density. Fish do this all the time. You may be wondering, how can a fish be underwater? Let's drop some water here. And then it can decide to go down or up. Well, fishes have a bladder. A bladder is like a place where you can put something. What they put in there is air. When they fill up that bladder with air, the volume of the fish changes. Let's say the fish had a volume of 1 meter cubed. When that fish takes in that air, its volume is going to change because it's going to get slightly bigger because the pocket of air makes the whole fish get a little bit bigger. The volume changes. So let's say its volume changes to, let's say, 1.1 meter cubed. That's enough of a difference that can cause the fish to move up or down in the water as it wants to move by making its volume change. Go ahead and write a question for number 3, and then have a good day. Don't forget to write a 4-sentence summary too, and then 1 advanced question. We'll check notebooks when we come back from